Now that we don't have to use the limit definition to find derivatives and we have these basic derivative rules, it's going to be a lot easier for us to do applications. Alright, so that's what we're going to do here, was we're going to look at applications of finding slopes, tangent lines, and then rates of change. Right? So we're going to start off with slopes and tangent lines. Alright, so use the rules of derivatives. So whenever it says use the rule of derivatives, you don't have to use the limit definition. You don't have to use the limit when it says. Alright, use the rule of differentiation, your power rule, constant rule, and all such, to find the slope of the equation of a line at the given x value or point. As the first example, find the slope to the tangent line of h of x, given, at 1 and 4 and compare slope. So in this first example, we're not asking you to find the tangent line. We just want to find the slopes at 1 and 4 and then compare, and what does it tell me about my function h of x. All right, so remember, slope, which is my rate of change, is found using my derivative. Alright, so before I get started, I'm going to rewrite this 1 over x part as well. I'm going to move the x up, so when I move the x up, actually I'm just going to rewrite the whole function so it looks right. 2x. And then when I move the x up, it becomes a negative exponent, and then I rewrite my square root as a negative 1/2. Alright, so I rewrote 1 over the square root of x as the equal power function, x raised to the negative 1/2. Now I can take my derivative. Alright, so I'm going to find my derivative using my power rules. So the first one is the derivative of 2x is just 2. Right? 2 comes along, derivative of x is 1. And then the power rule on the fractions, so negative 1/2 comes out front, x raised to the negative 3/2. Alright, so there's my derivative. And now I'm going to find it at my x value. So at x equals 1, the slope is equal to my derivative at 1. So again, I carefully plug 1, and make sure you're careful. Now 1's not too bad, but 4, if you're typing this in your calculator as an older version, make sure you put parentheses around the exponent negative 3/2. Alright, the slope at 1 comes out to be 3/2 or 1.5. Alright, at 1. Alright, there's at 1. Now the slope at 4. Well, I plug it into my derivative, and again, make sure you're careful. This one doesn't come out as nice. And again, make sure you put parentheses when you take 4. So it's 2 minus 1/2 times 4 raised to parentheses the 3/2 fraction. And so that comes out, not a pretty number, 1.9375 is the slope of 4. And so both of them are positive. So you can put this in your own words. All right, both slopes are positive, which means that both times h of x is increasing at both points, but it is slightly faster, I mean it is very slight, at x equals 4, right? If we're talking money, suppose this is profit, all right? At 1 unit, profit's increasing by $1.50 per unit. At 4 units, profit's increasing by $1.94 per unit. So it's a slightly bigger increase in profit at 4 per unit. Not much. Again, I use the word slightly because 1.5 and 1.9 isn't a huge difference, but it is a slight increase change. All right, next example. Find the equation of a tangent line, which we did these before with limits, and you still need to know how to do that. But now it's a little quicker. All right, I can find my equation of my tangent line and my quadratic at a point a little faster using the rules. All right, so I want my tangent line, which is y equals mx plus b. I find the m part using my derivative at my x value. My x value is negative 1, right? This is the x value, this is the y value. And so I find my derivative and plug negative 1 in. Right, so the derivative first. So the derivative of this is pretty straightforward. It's a lot easier than the limit. Right, the derivative of x squared is just 2x to the first. And the derivative of x is 1, and the negative 6 zeros out. I'm going to write that as a function. Right, now to find the slope that I want. All right, this finds any slope. I want the one at negative 1. Alright, so the slope that I want, that I'm going to plug into that equation, is -3, and so I'm going to find my b by plugging in all my parts that I have. So my y value was -4, my slope I just found was -3, my x value is 1, b is what I have to solve for. And so -7 is my y-intercept, and so the tangent at the point -1, -4, and only at that point. If I pick a different point, I'd get a different tangent, but the tangent at that point is the line y equals -3x minus 7, and there's my final answer. Alright, part B, so using the same equation, so the same, oops, went too far, so using the same function and its derivative, so I'm going to use the same function and its derivative. I've got a couple more questions to answer. Alright, so at x equals 2, is the slope positive or negative? Well, it's really easy to figure that out. Remember, the slope is the derivative. The derivative was 2x minus 1. And so plug in 2 to see if it comes out positive or negative. And so it comes out positive. Right, 4 minus 1 comes out 3. So it's a positive. I mean, it's an increase. And we know exactly how much it's increasing by, 3 units per change in x. Alright, still working with the same equation, so I'm going to use the same derivative. Is the derivative slope of my tangent bigger at 1 or 3, and what does it tell you about the function? So my slope at x equals 1 is the derivative at 1, which comes out 2 times 1 minus 1, so that's 1. My slope at 3 is 3 times 2, which is 6, minus 1, which is 5. Alright, so the slope of f of x is bigger at the x equals 3. Both are increasing, but at x equals 3, it's increasing faster. Again, if I'm thinking money is the easy way to think about it. If it's profit, because again, it's just an easy way to think about that, at 1 unit, right, profit's increasing by $1 per unit. At 3 units, profit's increasing by $5 per unit. Right, it's $5 change in, would be change in money over change in items, so it'd be increase of $5 per unit at 3. So it's bigger, so we like it. We're getting more profit after 3. It's a faster growth at 3. Alright, we'll stop there. We'll pick up the next applications, which are going to be more general rates of change applications in the next set of videos.